chapter. So we had a quiz. I believe it was exercise number 2. Is that right? The formula for so-called power rule to deal with antiderivatives is here. So we're going to have the power n plus 1 is divided by the same exact n plus 1. So you just add 1 to the power. When you took derivative, you subtracted 1. When you take antiderivative, you add that number 1 back. And therefore, for exercise number 2, I'm going to have to add 1 with the power of 7, right? Which is 8. So I'll divide this by 8. And of course, put a plus the constant. So x to the power of 8 over 8. So this is our little answer, and that's nice. And I guess the quiz exercise done. So in the case if someone did not make it correctly, you can always do the extra credit problem, and you can send me any exercise of your choice. So you just give me something, but whenever you're ready, just email it to me. Let me do one more problem here. Let's say exercise number 16. We also going to use power rule for antiderivatives. So it looks like it's a cube root. So 3 will be in denominator. Whatever you have as index of your radical, you put it in denominator. So I wrote this as a power. And now I'm going to have to add 1. That's what the formula says, right? So I'm going to have to take that fractional power, 2 over 3. And instead of adding it with number 1, I add with 3/3, right? This is same as 1. So it's 5 of those thirds. So we are going to get the arithmetic done in such a way that x to the power of 5/3 is going to be in my numerator. And then 5/3 will be in denominator. And please also notice that we always add the constant, right? So all formulas with antiderivatives want to make sure that you put plus the constant. And say, what constant, Alex? Well, it could be any number. Could be number 5 or 55 or any number. In fact, there'll be later exercises that will ask to find that constant. But for now, we just keep plus the constant. So since 5/3 is in denominator, I write it as a 3/5, 3 over 5. And now for x, I can go back to the cube root. So I can write it as x raised to the power of 5 inside the cube root. Doesn't really matter. You could leave the answer the way it was, but maybe in the back of the textbook, they like to use that radical, since original problem had that radical as well. So whenever you have a x, some power of x, you want to put this in your power rule, except for exercises like 20, where you're trying to integrate 1 over x dx. So notice that 2 I took out. 2 is not participating. Just like when you differentiate, it doesn't matter. You just multiply by that number 2. And now when I take the antiderivative of 1 over x, I get ln and plus the constant. People also like to put the absolute values just to make sure that logarithm is taken of positive number. Well, you can do that, but you don't want to panic. It's just to make sure that function logarithm is defined. Just like square root, we also square root only positive numbers. We can't square root negatives. So let us do one more and try to move on. So exercise like 29 here that also utilizes one of those special formulas for the antiderivatives. And that's actually my favorite formula, e to the power of x. Derivative of e to the power of x and antiderivative of e to the power of x is exact same e to the power of x. That's why it is my favorite formula here. But I need to pay a little bit of attention to the actual power, because my power here in exercise 29 is 7x, right? So what I used to do, I would guess the answer. Remember last time when we started this section, said to myself, well, the chain rule will keep the same thing, e to the power of 7x, but then 7 will be put on the ground, and then I need to make sure it cancels. So the answer should look somehow like that. And of course, there's a question, how do I know, right? So the 7 needs to be in denominator. And the answer to how I know this was to, well, check it out. So you just get this result that you produced, differentiated. So when you find a derivative, that 7 is going to be untouched, it's in denominator. E to the power of 7x is going to stay. But because of chain rule, I need to multiply this by derivative of 7x, which is 7. And plus the constant, which is derivative of constant is 0. So it just cancels. So when 7s will cancel, I'm going to get back what I started with. And I guess this is the point of this procedure of guessing the answers. I know that it's not very pleasant to guess the answers, so I want to show you another way to get the antiderivative found, which is a standard way in the later sections. So what you're going to do is to write this as a new function, let's say u. They really like that letter u of variable x. So when they take derivative of 7x, that'd be just a 7 because x disappears. And I can write this as du over dx. When I say u prime, Alex, you like u prime? Yes, I do. But for this case, I put du over dx to actually be able to cancel that denominator. So if I'm multiplying by dx on both sides of this little equation, then we can cancel denominator. And then we can say that 7 times dx is equal to du. What does this mean? Well, I go back to the original integral and substitute. So now the power of letter e will be 7x changed with new variable u. And that's what I like about it. Now I need to also replace dx to substitute it. And notice that there is 7 on the way. So I'm going to divide by that number 7 on both sides. So dx I'm going to replace with du over 7. And that number 7 appears in my denominator, just like we had when we guessed. See? So 1/7 is going to stay. And then e to the power of variable u is going to be e to the power of 7x. Let me write it e to the power of u so we don't skip any little steps. So e to the power of u, it doesn't matter for this formula. If your variable is x or a u or z, it's still going to be the same thing. And plus the constant. And finally, I'm going to go back to my original variable x. So I'll put 7 in denominator, e to the power of 7x in numerator, and also plus the constant. So this will be the result of that integration. You say, Alex, I liked better the guessing approach. Well, it is up to you. But today I'd like to show you some of these substitutional exercises. And to do that, I need to skip a few sections. I'm going to return back to them, so please don't worry. I want to go to the sections that called substitution, and that's section 4, I believe, of this chapter. It has nothing to do with the previous sections, so I just want to do a few problems in section 7.4 that does exactly the same thing. Oh, that's not that yet. 7.5. Let's see, you skip and lots. Well, I know this book they just created in such a way they all of a sudden squeezed something different in it, and that's why I really want to leave it out for now. But of course, after we're done with 4.5, I will definitely return back and do rest of chapter 4. So it looks like we have some of the practice that we already saw before, these 3 formulas that we worked with already. So we continue with the story, and they now are talking about the antiderivatives and the substitutions, like an example. Well, maybe I'll just take the example myself and do it, so it'll be better. How about exercise number 1? So I'm looking at section 4.5. I'll do a few problems like exercise number 1. So you start to get used to this procedures. So I'm going to be integrating here 8 plus x cubed in the parentheses. And this is raised to the power of 5. And it's also multiplied by 3x squared dx. So we now going to do the substitution. We're going to replace whatever is in the parentheses with that variable letter u. So for some reason, when you do this antiderivative process, you always utilize the letter u, but you can use any letter you like, but definitely not x, because x is already taken. So then I take derivative of this substitution, and that's going to be 3 times x squared, right, is equal to du over x. So what people do, they just put du automatically on one side and bring the dx to the left, so they don't have to write it like I did here with that mess that was created. But I guess the idea is that dx could be brought on the other side. So look at what we have now. Something is very nice. Parentheses I replaced with letter u. So we're going to end up with u raised to the power of 5. And then whatever is left over, 3x squared dx is my du. I say, it looks like they did it on purpose. Gave you such a nice substitutional exercise. Yes, that's the first problem, so we definitely can enjoy it. But my goal today is to just get used to these substitutions, because I can take antiderivative, right? Power of 5, I can add with 1, and this will be a 6. So I'm going to divide this by 6. Don't forget about the constant. And then write the answer. Instead of letter u, I go back to my original variable x. I put it in the parentheses, just the way the substitution looked like, and it's raised to the power of 6, n plus the constant. I know this is different. This stuff is different, so I don't think I'm going to give you a quiz today because it's really something you want to get used to. And my advice will be, well, just to do the same problems that I'm doing right now. So I'm going to do a few substitutional exercises for you so you can see that this process is really the same. Whatever is in the parentheses, you don't really care what's in the parentheses. You replace it with new variable, with letter U. So exercise number 9 has a ln in the parentheses. It says ln of x, which is cubed, and then it's multiplied by 1 over x and then dx. Well, let us replace ln x with variable letter u. Again, because it is in the parentheses. So derivative of ln is, remember, 1 over x times dx, and this is equal to du. So I always separate this. Dx goes with x's, du stays on the other side. And then, well, good thing is going to happen, because once you replaced your parentheses with a third power of u, then you're going to be able to integrate u to the power of 3, and the rest of this is actually here, du. So it goes under the favorite power rule of integration formula. So we're going to add 1, right? So u will be raised to the power of 4. 3 plus 1 is divided by 4. And also plus the constant. So finally 4 is on the bottom. And instead of letter u, I put ln in the parentheses. And this whole thing is raised to the power of 4. And plus the constant. So this is it. We got it. And this is nice, right? So let me do another one. Looks like the good thing to know is a pattern. And one can say, Alex, some exercises here do not have parentheses. So what kind of pattern you're talking about? Well, notice the problems like exercises number 12 is something we already did in the previous section. So let me try one that does not have parentheses, like one with denominator. And the hint is, whenever you have denominator, treat it as your parentheses. In other words, always try to substitute your denominator, and that's another very popular way to go. So whatever I have to integrate in here, I'm gonna replace my 1 plus 2x with a variable letter u. So then I'm going to take derivative, which is going to give us 2, and then dx will be attached to it. And that's equal to du, right? So we actually have it all prepared. Look at this. 1 plus 2x is my denominator, and that's going to be letter u in denominator. And now the remaining part, whatever is in numerator, will be 2 times dx. And this is exactly du. How about that? Du over u is something we just integrated, right? It's ln, isn't it? Ln of u and plus the constant. So I'm going to put ln of this 1 plus 2x. Replace, always go back to your original variable. They like absolute values, and plus the constant. And this is it. So it's a nice set of exercises here, in a way. And I highly recommend you again to maybe not tonight or tomorrow, get a piece of paper and do the same problems once again. Let me do problem number 25. Maybe I'll stop at this stage. Don't want to overwhelm you with this because I want to spend another day for this section because I think this is a key section of the rest of the class material. So we really need to start feeling better about this substitution process. So we already know how we start. We're going to need to replace parentheses. Actually, it's t squared minus 1 with variable letter u. So let's take derivative. It's a 2t, and I automatically attach dt to it. It used to be x, now it's t. Doesn't really matter. It is du. So here comes a bit of a problem because after I replace my parentheses with a u, what remains does not have number 2. And that's okay. What you can do is divide by 2 both sides. So that 2 is going to cancel. And this way you have left with t times dt, and that's exactly going to be a fraction du over 2. So u to the power of 5. And then we multiply it by t dt, which is du over 2. So that 2 went to denominator. But we don't care. It's a constant. It could be numerator and denominator. Doesn't really matter to us. All I care about is use the favorite power rule for antiderivatives now, right? So the power will be 5 plus 1, 6. And I divide this stuff by 6. So I put another 6 in denominator and add the constant. So it looks like it's 12 on the bottom. And then instead of u, I have t to the second power minus 1 in the parentheses raised to the power of 6 and plus the constant. So I guess I want to stop at this stage with first page of section 4 or 5. In fact, don't go any farther beyond exercise 42 because problems that start at 43 will do later. So far, I just want to practice with this substitution so you feel better and better about this, and eventually, I hope you're going to like it. So I'd like to go back to the beginning of the textbook and see what our plans are for the rest of the semester, because looks like we have 3 full weeks of class left. Because our final will be on the first Tuesday of May, and it's about 4 weeks from now. So we're going to do a review, of course, just like we did before the midterm. I will send you a practice final. Then I'll give you the final exam. And then I'll have another class meeting to see your feedback on this grading and stuff. And we can always meet again. And if you want to get better results, I will never mind. So that's why I give final on Tuesday, not on Thursday. So Thursday, I reserve Thursday on the first week of May. I will reserve for very, very last meeting. And just in case if something happens, so we can always fix it. So I'll be working on sections 4.1 through 4.6 in this chapter 4. So we're already looking at 4.4. We'll continue with it next time, and then we'll go to 4.2, 4.3, and then we'll just keep dealing with this chapter 4. And then maybe I will also look at a couple of sections in chapter 5. We'll see how the time goes. So we are pretty much done with the, will be pretty much done with the material after we're done with 4. And as I said, there are going to be like 6 class meetings left for the new material, because then we're going to do a review and then we're going to have a final. So it's not much time. And it's good to start to catch up with your homework. That should be the plan for the rest of semester. So far, looks like most people doing very well in this class. I'm pretty happy about this. I'm satisfied with grades. And if someone wants to turn in some work, please email it to me. Whenever it's ready, I will accept it. Just make sure you email me that work of yours. And I guess that's pretty much all I wanted to talk about today. So we'll be continuing with section 4.5 on Thursday. I'm going to stop to record.